have a bit of a plan at this point. I am going to talk about one thing with one of the studies. So, again, don't forget, at the end of the day, like, you need to write in reference to the goal of the study, right? If your goal is to make an inference about a population, you've got to write about the populations, the sample, the characteristic of interest, what was done to reduce the effects of bias, what could have been better done to reduce the effects of bias. You got an experiment, right? We got to talk about the inference about causation and what explanatory and response variables there were and things like that. Experimental units, treatments, what they did to reduce confounding. Now, the last thing I do want to point out, Emerson was asking a really good point. He was asking, hey, when was this racial identification study done? Is there a way to find that out? So the racial identification in preference and dolls was a landmark study that was done in either the late 40s or early 50s. And the reason why it was important is because, and I'm going to kind of give some things away here, the researchers Kenneth Clark and, Mamie Clark? I don't know. But they showed a connection, and I'm not going to say if it's causation or not, between someone's racial identification and the preference for the doll that they had. Now, I want you to think about, when we're talking about black children in the late 40s, early 50s, or just our society in general, what major issue was there, especially the one that, Brown v. Board really started to break down? Segregation, right? Separate but equal. That was very clearly not separate but equal, right? So, in this study, they start to note and say, hey, look, these girls are identifying race in these ways, and it has this relationship with the dolls that they're choosing. And so that really started to call into question. Granted, it didn't start to call into question. There was always these questions around separate but equal. But it was the landmark case that without this, Brown v. Board doesn't happen. There were actually lots of lawsuits. I won't say lots. There were several lawsuits before Brown v. Board that desegregated schools. But this was the study that showed the problems with separate but equal. Okay? So that's where this study comes from. So this is one of the reasons why I love study design, right? Like, when we talk about the real world, study design is one of the most important things there is, because we need to know how to talk about studies. Colleague here, I mean, obviously you can tell my classroom is not 100% set up like other teachers' classrooms a lot of times, especially with the desk already in groups, that's the focus. A colleague sent me an article kind of pushing back on my approach to teaching with this article that was talking about how desk in rows, it was actually an experiment, so they could show causation, but desk in rows caused a 50% reduction in misbehavior in a classroom, and showed that students were much quicker to get on task. But then when you look further at the study design, there's major problems I had with the study design. One, the sample size was only 3 classrooms. That doesn't sound like a lot of replication to me. The study design was 19 years ago. I can tell you this, 2006, students operated much differently than they do in 2025. 3, all that the focus of the study was on was causation for behavior and time on task. And I can tell you this right here and right now. There's a lot of students I've seen that are good at mimicking and writing garbage down on a sheet of paper, but they haven't actually thought or learned anything. I care about thinking and learning, so I don't just want to care about having proper behavior. I want to think and learn, and so we got to go beyond that. So this is where it's important, and I haven't gotten a chance to talk to this person yet, but I'm going to heavily push back on that. I'm like, is all you care about kids misbehaving or not? Because I don't. As a teacher, like, I want kids to think and to learn. Like, I want them to grow. I want them to communicate and collaborate with each other. So those are the things, like, when we talk about study design, I love a lot of the stuff we're going to study eventually because it gets more into the mathy stuff. But gosh, if you don't understand how to analyze and break down a study and question the study, then people are going to make claims. They're going to send you articles like that, and then you're going to be like, oh, this is what's valid. No, that's not valid. Oh, last detail was, it was only sample size of 3, but it was also very specifically done in a classroom that was in, like, behavioral issues, classes where there were, I believe it was special education classrooms where behavior was a problem. Is that something that I should apply to my regular classes or even my AP classes? No. There's no generalization to a population there. It's like, this is why study design matters, right? When we don't understand that study design, we get information that's bad and not relevant to what we do. So, hopefully that was a little bit of good insight why I care so much about this stuff. So, yeah, I'm gonna pass back your DYUs. I'm also gonna pass back your test really quickly, and we're gonna go over a couple of things. Now, I haven't actually put your test in. My bad. I will do that today. I have put your DYUs in. With the test, the class average was an 81, but the highest was like a 91. I assume some of us want a little bit higher than that, and so I'm going to do a retest. Okay. It is not going to be the same test, obviously, because I need to assess that you've learned it, not just can memorize something. So I'm going to go over a couple of things I need you to pay attention to for the future. And by the way, guys, this is the first time doing an AP stats test. Things are going to be a little bit different than what you're used to. So learn from it, grow from it, right? Dixie, I was mentioning that in between second and third block. If you learn and grow, I'm going to take care of you. That's it, right? I was talking to another student, not to Dixie, but I just need you to learn and grow, and you're going to be fine. So, a couple of things to be aware of, and I think everyone who took chemistry, the initial chemistry exam was rough, right? Well, it's a learning curve, right? So, well, why do you say it that way? It was terrible. Ethan, are you the only one back here? Oh, you know 9? This is 8s, right? That's 9s. Okay.
I will be making that test though.
All right, Charlie.
Wait, you said the.
Okay. Lorelai. This is the test.
Okay, 1, 2.
And Kinsey.
Oh dear.
Hello?
Thinking. I talked about thinking. My bad.
Wait, how much did the same thing Mr. Dallas did for years?
Seriously?
I know.
Sorry, guys.
Every time I'm
Hold on.
I didn't do that.
I'll put the grade
Wait, no.
Ethan. Kinsey, I'll get it right this time. Emerson.
Is this on?
Yes, it is. Raina. Phoebe. Dixie. Lorelai. This is DYU. Ian. Sophie. Leah. Okay, and Star. All right. Couple of things with your test. All right, hey guys, listen up. So we're going to go over some key questions from both the test and the DYU that I need us to learn from. But one of the things I want to let you know about the test is on the AP exam, you can get about 70% of the questions right and still earn a 5. You can get or 70 points on the test and still get a 5. You can get about 44 points and still make a 3. Okay? Yeah, like there's 100, oh, by the way, that's out of 100 points, right? So you don't have to have a ton to be able to get a passing score. It is very, very doable for everybody. So one of the things that I learned at one of the very first AP workshops I ever went to was something called a square root curve. So each multiple choice question is worth 1 point. Each free response question, just like on the actual AP exam, is worth 4 points. Now, the way that the free response questions work is if you got all E's, so if you got 3 E's, you get all 4 points. If you got 2 E's and 1 P, you got 3 points. If you got 3 P's or 1 E with 1 or 2 P's, you get 2 points. If you get 1 E or, so then the rest I's, no P's, 1 E or 2 P's, you get 1 point, and if you don't meet either of those criteria, you get 0 points, okay? So, from there, what I do is I add up all your points, and so let's just say you got 9 out of the 16 points, okay? Obviously, can someone type in 9 divided by 16 in the calculator? That's what? 0.5. So 56%. But remember, you only have to have 44 points to get a 3, right? Which is roughly a C, right? Now we're only focused on one unit. So what I do is I take a square root of that score. Now if I take the square root of 9, what do I get? 3/4. And so that is a 75. So by taking the square root of it, it actually scales the score up for everybody. But it helps people at the bottom end a little bit more than those at the top end. So notice if you take the square root of the number of points you got out of the total number of points available, then that's how you get your score. Again, I'll put that score in. In the same way, like if you take the square root of 0.81, and 81's a low B, right? But the square root of 0.81 is 0.9, it's 90%, right? So notice it doesn't scale it up quite as much for that top end, but it does scale it up for the lower end a little bit, okay? A little bit more. So I believe that's all I wanted to talk about with those different, with the scoring. So yeah, I do a square root to scale everybody up. But what I want you to remember, and I want you to focus on, and I don't know if I've said it in this class or not, or if I've just said it in Algebra 2, at the end of the day, I really don't care when you learn it, I really care that you learn it. That is the focus. You're going to have to take an AP exam at the end of this, and I want you to get college credit. And I want you to earn the score, or the grade that you want in this class. So one, you're definitely going to be able to do a retest for this test. But don't forget, and I haven't updated them yet, or actually done them at all yet, but I will this weekend probably. Your DYUs are only 10% of your overall grade. Projects, 20%, which historically, especially after a final draft, projects are really good scores and help students a lot. Tests are 30%, and your proficiency scales are 40%. And it doesn't matter when you show me that you understand these ideas for a proficiency scale, you can always get the concepts marked off. And so remember, I have a proficiency scale for you. So show me evidence that you understand these ideas, and you're going to be good to go. That's literally almost half of your grade, right? It's not in the grade book yet, but it will be at the end of the 9 weeks. So please trust me. I will take care of you. You keep working, you keep learning, you keep growing. You're going to be fine. Because I want you to grow and learn more than anything else. Okay? So don't get frustrated, don't get down on yourself. Take it as a learning opportunity. When I learned to start focusing on the learning side of things and not just performing at a high level all the time, that's actually when my grades shot up the most. I took everything as a learning opportunity, and I was also happier. That was a big thing. Instead of just, oh, I have to have an A, I started focusing on learning it. It really did help me be happier. All right, couple of things before we start going over so I'm going to go over a couple of things with the test and the DYU. Don't forget, progress check A is due tonight. The DYU through 1.4 and 1.5 will be sometime tomorrow, and so we have a Frere model due tomorrow, front and back of page 1. Okay, so there's those details. I'll put that as a reminder at the end of class. Okay, really quickly, this is one that got a lot of us. Number 7 here. I want to say that the more common answers that were wrong were maybe C and D. Were some of us thinking C or D for this one? You were thinking which one? D as in dog? Yeah. C as in cat. Okay. So here's the thing, when we look at C, it says, for the category that joined the workforce, the number of students from each school was equal. So join the workforce, look here. There it is, right? But what does this y-axis say?
20% of each school.
20%, or the relative frequency is the same, right? But notice, how many did we have from Liberty High School? 100. And how many from Central?
60.
Right, so 20% of 100 is 20. 20% of 60 is 12. Is that the same number? So remember, we have to understand the difference between the relative frequency and the frequency. And so pay attention to those small details. D, dog, got a few of us. At Central High School, and I think the big one here was we looked at the wrong bar, but at Central High School, the same number of students selected four-year university and military. And if you looked at Liberty High School, you had the right answer. Liberty did have the same. 20% and 20%. Madeline, is that what you did?
Probably.
Yeah. Notice though, we have to be careful. Central High School does not have the same number. Notice I can say the same number for Liberty because it's still 20% of 100 for both. Does that make sense why C and D are out? Understand how to learn from that? But E, for the category undecided, the number of students from Liberty High School, so undecided, there's Liberty, that's 10% of Liberty, which is 10. And undecided from Central, that's 10% of 60. Is that 4 greater? Yeah. So remember, typically with these comparative bar charts, we only look at the relative frequency, but if they do give us the sample size, then we can calculate frequencies as well. Do we understand how it's getting those frequencies, by the way, the 10% of 100, 10% of 60? I know some of us were saying we didn't love relative frequencies or percents earlier, so if I need to clarify anything, please let me know. Okay. So just remember, you just take the decimal and multiply it by the total. Okay? Okay, so this one came up, someone was asking about this. So I'm going to focus on this idea of is there an association or not. And so I'm going to talk about 2 things with this. First off, it's going to make a lot more sense when we get into probability, but I want to go ahead and talk about it here because it will help you when you get to probability. What proportion of the days does she play the announcements? Here's my announcements. That's 44 out of the 55 days for that marginal relative frequency, or 4/5. When Mrs. Gallus does drink coffee. So notice I'm not looking at every day, I'm only looking at which days? When she drinks coffee, so I'm only looking at this group here. What percent of the days does she play the announcements? So that's 32 out of 40 days. And that simplifies to 4/5 as well. So let me ask you a question. Did it matter whether she drank coffee or not for the proportion she played the announcements? So it didn't matter. So was there an association? No, they were independent events, right? So notice, like, it didn't matter that condition or not, so there was no association. One thing I want you to see is actually, so 2 things. I'm going to show you a really cool thing that I found recently. So this is StatsMedic. If you look for StatsMedic applets, and you click here, they have a whole set of applets set up that can help you make graphs. Okay, so notice we have 1 categorical variable, a single group, 1 categorical variable, multiple groups, or 2 categorical variables. And so I already entered this data right here. So notice, here's the drinks coffee, here's plays announcements, there's the data, begin analysis. Okay, what do you notice about those? Yeah, you look at those stacked bar graphs. Does it matter whether she drank coffee or not? No, it's the exact same. Notice I can actually change this chart type right here to mosaic plot. And notice how it was now proportional to the fact that she drank coffee more days than she didn't. A lot of us noted, hey, she drank coffee and played announcements more frequently, but it's not about the frequency, it's about the relative frequency. Okay, so there was no association because those relative frequencies were the same. Yes, ma'am?
How can I put it in words so there is no association because?
Because it did not matter whether she drank coffee or not for the relative frequency that she played the announcements, right? Remember I showed that the relative frequency was the same no matter whether she drank coffee or not. Yes?
So can you explain for E, because I got an E, but I said yes.
It was because you based your answer on B and D, which I think you had your B wrong, didn't you?
Yeah, yes.
So your relative frequencies were different. So if those relative frequencies are different, you should say there is an association, right? So that's the thing with the AP exam as well. We read with your mistake. So if you made a mistake in B, but you apply it correctly to E,
It's consistency.
it's consistency point, yeah.
Thank you.
Yep. So it is definitely supposed to be no, there's no association, but you have to get B and D right to get that. Does that answer your question?
Yes, sir, thank you.
Okay, y'all heard me a little bit on this one. First off, in A, and it says identify the variable. Guys, make sure you identify the variable. Y'all identified the fact that it was categorical, but you didn't actually identify the variable. So a lot of us only got a P there on A. Second, a whole bunch of you did not make a segmented bar graph. You made a bar graph.
Wait, I thought this was the one.
I'm gonna cry.
Segmented. The segmented had to stack up to 100%. So I stole one of y'all's and showed it. Please notice, you need to make a key, and you need to make sure you check tools. Did you put your title, your units, your label, and your scale? And it could be a little bit cleaner here. But yeah, notice it needs to stack up to 100%. So 32% was rock. So that went at least close to 30%. The next 15%, which got us up to 47%, was pop, right? So you need to make sure that those widths were the same to get up to that 100% or close. Do we see the mistakes we made to learn from them?
Oh my gosh.
I feel so slow right now.
Don't be slow. Don't be slow. Don't feel slow. Okay? Don't feel slow.
Oh, but I do.
But here's the thing, and this is what I need you to remember and to think about. It's just learning. Like, learning takes people different
Oh,
times.
sure, we did learn.
But that's fine. Guys, different people have to put in different amounts of effort to master certain things. It didn't take, I mean, it doesn't though. Like, I mean, everyone has a different starting point, and it's learning to figure out what is your strength and what's your weakness, right? So, I will never be able to play soccer the way that you're able to play soccer. If I practice more, I would get better at it. But like, you're better at that because that's what you pour your time and effort into. I never had to stress a ton about math when I was in high school because that's what I was comfortable with. English, completely different story, right? Like, I had to pour over my essays. I had to study my grammar a ton. I had to study the books a ton. Everyone has a different starting point. Everyone has different strengths. The trick is getting comfortable with where you are and working to get better. If we understand that you can grow, then you don't have to sweat all those small details. All right, really quickly. So here we got this data. We needed a stem and leaf plot. Please make sure you don't put commas in between your leaves. Don't forget to actually still make the title, the units, label, scale. Now, I went off of the AP rubric, which didn't ask for all those things, but this was an older question. They would definitely ask for that now. But make sure when you do a key, you say 10 what, right? Like, you do need units in there. Yeah, so we need to make sure we have our key, our units in there. All right? Now, here's what I want to talk about here. So I allowed credit, I think, for full credit on this one. Please do not write your response like this on the AP exam. You need to cuss in context, but you need to write a sentence or two. They want sentences, not just checks, right? So, a typical number of questions correct is 18. Total number of questions correct on the econ test, I should say, is 18. The median. But the range is how much?
36.
It's 36 questions.
Yes, because I put approximately, but she crossed it off.
Yeah, it's not approximately. The range is 36. It goes from 8 to 44. 44 minus 8 is 36.
I thought we always had to put like.
If you do the actual calculations, and you know it's 36, it is 36. Shape, say approximately. Okay. But if it's very clear something is, okay, so the range is 36 questions. Notice by this time I have center, I have spread, and I have context. I still need unusual aspects and shape. So for all of you that thought this was unimodal, do you see that massive gap there between 19 and 33?
No.
There's
I see it now.
nothing here. So, to make it more clear, I did pull up again I want you to notice Statsmetric applets are really good. So I have my data in here, begin analysis. And so you could have done this on the test on your calculator too. Look at that gap. Are you telling me that that's unimodal?
I thought you could just go over it.
Not if it's a huge gap like that. If it's a little dip, sure, but that's a big old gap. Look at that histogram. Look at that massive gap.
What gap?
What gap? Right? We're doing a histogram. Notice this may make things more clear. The histogram is bimodal. I don't even know that I would talk about skewness because there's not really skewness, but it's not really symmetric. I would just say it's bimodal with a gap between 19 and, I was at 20, because there is a corrective of 19, 20 and 33 questions. I cussed in context. Okay? Yes, sir.
You said that you wouldn't really put skewness because there isn't, but
Yeah.
put that it's skewed when you check it.
Yeah, I said I wouldn't really put skewness. I'm not saying that I didn't give credit for that. Yeah, I personally wouldn't say much about skewness here because it's not really skewed, but it's not really symmetric. So I just would have said it's bimodal with a gap. Okay. All right. So from there, the only other thing with this one I think was, oh no, that was the test. Yeah. So I try to give feedback. Let me know if you have questions. Y'all, you killed me on this one on the test.
That one
So which
was so
one's that?
hard.
Y'all thought this was number 4. This was number 4 on the
I
test.
thought it was A, and I just put none.
But
Well,
I
that's actually
I think what y'all got distracted by was number 2. But guys, we use a simple random sample in stratifying, but is stratifying a type of simple random sample? No. No, that is, stratifying is not a type of simple random sample. Is it a type of a random sample? Yes, but not a type of simple random. So yeah, number 4 was A. I think everyone thought it was 3 and 4, but 2 is what threw some of y'all off. It is not 2.
So I thought it was like none because I thought there was more to it.
Nope, 3 and 4. It's not a simple. Literally, also, you couldn't say 2 and 3 at the same time. Like, you can't say it's a type of simple random and not a simple random. Those are contradictory pieces of information. All right, we're going to talk just here after lunch. Please hurry back so we can talk about it. And then we'll start on the next lesson. Yes, you can use my microphone. What is wrong with stress? So, like, the reality is, yeah, right? Like, if you check,
I forgot it.
but if you did 19 for anti-remedial, that doesn't tell anyone anything about this because of that giant gap right there. So the gap is creating a problem.
Actually said no, it's
If you do a mean, which is not typical.
I made up the AP kit test.
So you needed to talk about, you needed the, so yeah, you just talked about this one of the 4 parts of cuss, but like, why do you need
Somehow I got points
cuss?
for that last week.
Because
I had like 2
the
cents.
center does not get even close to the same picture. But you did better on the test, so keep focusing on growth and learning.
No, everyone kept coming up to me, talking to me. I'm like, I kind of ran out of time.
Yes, maybe it's not this. Sorry, she was saying it's part of class, but I'm gonna get you there.
Okay, I don't know what happened yesterday. I haven't been sleeping good, bro.
I agree. Listen, but this is my focus. I don't care when you learn. I care that you learn. You're gonna be fine.
Trust me, I'm gonna learn.
There you go. If you open, how Ian? If you look in the table of contents, it will tell you it's the one that's titled like exploring one variable data or something like that. If you also want to just take a picture of it, email me the table of contents. I can tell you where to look.
Okay.
But it's going to be chapter 1. Yeah. Sorry, I need to go back and check with Mr. Hinton about the ordering of the new textbooks, but they haven't come in for sure. Okay. So number 8 here on the test. Study was conducted that investigated the effect of brisk walking on retention of visceral fat around the midsection. researchers randomly assigned 60 adult volunteers with significant amounts of visceral fat to one of two groups. I'm gonna stop right there. What should we immediately be thinking about based on that
It's an
info?
experiment.
So we got an experiment, what else?
Randomization.
Generalized, it's not, it should be not generalized because, I mean, it's an experiment. It doesn't need to be general.
When you say generalized, I mean, you mean not an inference to the population. So not an inference to the population, right? But we do have an inference about causal relationships, causation, cause and effect, right? So notice, D and D are out. We can have cause and effect. And I think the biggest thing that got students was A and B. But notice A says to all adults, but I can't generalize to the population. And I do want to point out C says there is convincing evidence suggesting that brisk walking caused a decrease in visceral fat for the participants in the study. But we already have the individuals in the study. We don't need statistically significant results for those in the study. We need statistically significant results about all like those similar to the study. So it is going to apply to all adults similar to the ones in the study. So that's not an inference about the population, but if you're like those in the study, I know about causation.
Can you like elucidate on like why you couldn't generalize this to everybody?
Well-
It's not a census.
It's what?
It's not a census.
Well, census, I wouldn't have to generalize to everybody anyways, I would already have the data for everybody. But what do I not have that is necessary to generalize to a population? What kind, I mean, I have a sample. I have to have a random sample. Remember, you have to have random sampling to reduce the effects of bias. So I don't know about all adults, I only know about the ones similar to those in the study. Does that make sense?
So basically, like I was kind of like, do you think I was thinking about it in observational study?
Not necessarily, what happens oftentimes with students like that on that question is they don't realize that we haven't reduced bias. Remember, this sample doesn't necessarily look like the population. Does this sample necessarily look like the population?
No.
No, they were all volunteers, right? So I don't know that they look like the population. I just know cause and effect because there were statistically significant results. Does that make sense? Okay, is there another question? Okay, free response, just a couple of details I wanted to point out here. So same thing, the biggest thing I need you to remember is on B, right? So during the course of the study, the subjects will have their cholesterol levels measured each month by a doctor. This is number 9. The researchers will perform a significance test at the end of the study to determine whether the average cholesterol level for subjects who walk fewer miles each day is greater than for those who walk more miles each day. So selecting a random sample creates a reasonable representative sample. So like some of y'all talked about random sampling reducing bias, but remember that's literally what they're saying here. When you have reduced bias, your sample represents the target population. They're already saying that. Okay? They're already saying that you have a sample that reasonably represents the population. So what's the benefit? What can I do if I have a sample that looks like the population? I can what? I can generalize to the population. I can make an inference about the population. Like that's what we should have talked about, but you've got to remember context. That's one of the biggest things that students miss on this one. So you could have talked about making inference to the population, make an inference to the parameter of the population, but you had to talk about context. So we can make an inference to the population that the amount of walking is correlated to the average cholesterol levels for subjects, right? So the population of all people, I don't remember what the population was, but random sample so we can make an inference about the population. And then context, I think is the biggest thing there. C though, y'all heard me on this one, and made me realize I need to address this better. We had statistically significant results. So the question was, can we talk about causation? Hey guys, do we have an experiment? Do we have treatments? So can we determine causation? It doesn't matter that there's statistically significant results, that just means there's a correlation. If you ever want to make a claim about causation, you have to have treatments in an experiment. I need you to remember that. So it doesn't matter whether the results are statistically significant or not, that just shows that it's statistical significance, remember, shows that it's so unlikely to happen by chance alone that I don't think it was chance, right? I think there's a difference. But if I don't have an experiment, then I don't know that it was causal. It may have just been a correlation. Or it just may have been a difference. So please keep that in mind, okay? So those are the two big things that a lot of us missed on that one. And so I wanted to address that. Hopefully that improves our understanding with those two pieces a little bit. Because remember, it's not about when you learn, it's about that you learn. And so work with me, and I'll work with you, 100%. Yes,
Do you
right.
have any expected dates for retaking tests?
So the retest will be next week, so Tuesday through Friday next week sometime. Either before or after school, or maybe, so like I could do it during first block if you have time then, or Miss Granberry across the hall has fourth block planning, so we could do it during fourth block. So any of those times, but it needs to be next week. I would highly recommend working through the test, looking at the questions that you missed, come in and ask me questions. If you need more explanation about different details, I would go back and look at the FAIR models, which I will try to get those, the ones you resubmitted last time, I'll get those done tonight, I hope, and return those to you tomorrow. And do some practice problems. If you want to redo a progress check, you can do that, but, yeah.
So we're doing it separately, like not doing it in class?
Correct. It's a retest. You gotta come in on your own time to do a retest. So before school, after school, first block or fourth block. Okay? Let's get it done next week. I will say, I used to let people just come in, but what I found is when I give that nth amount of time, people just kind of wait too late and then they forget everything. One, please make sure you actually study. It does not help to come in and do a retest if you haven't studied the concepts, mastered the ideas, and the procedures better. Make sure you also pay attention to your AP exam tips in the textbook, because one of the big things I noticed was that a lot of us, when we talked about bias, did not, in part A up there, did not talk about over or underrepresenting the population, right? Pay attention to your AP exam tips. Those were written by Josh Tabor and Darren Starnes, who are literally two of the biggest deals in the AP statistics community, right? They've been chief readers before, they've been doing it for 20 to 30 years. I think Darren Starnes may be closer to 40 years at this point. Yeah, he's been there since like the beginning. And that can't be right. I don't think stats started until the 90s. So 30 plus years for Darren Starnes. All right, let's get started though with today's lesson. Oh yeah, here, sorry, I forgot about this one piece, number 10, part C. So, in this case, did we have an experiment?
Yes.
Yes. So this is number 10, the concrete fibers. So if we had statistically significant reduction in the mean severity of cracks in driveways, what can we conclude? Cause and effect. You had to talk about that. Statistical significance in an experiment allows us to make an inference about cause and effect, and then make sure you have context in there. Those are the biggest things, context with cause and effect. I think some of us may have actually I think a lot of us wrote about reducing the effects of confounding, which is correct, but why do we care about reducing the effects of confounding? So we can make an inference about cause and effect. Like, that's the ultimate goal, right? If we have statistically significant results and we have that random assignment, yes, we reduce confounding, so we can make an inference about cause and effect. Okay? Ready to get started for today? Where is my papers? Yeah, thank you. Let's get through this a little bit. No, I already made scans of it, so you can hold on to it. Yep. Okay, so we got to here the other day. There's 1.4. Which city has the better weather? Okay? So I'm actually going to put a pause on this. Go ahead and get this out, but I want y'all to see something that I remembered the other day that can be very, very helpful. So right here, I want you to notice, it says right here, another way to measure variability. So what's the only way we've talked about variability so far? Well, we've called it spread, but there's one way that we've learned to measure it already. The range, right? So the spread is our variability, but we have measured it through the range. But we're going to look at the average distance of the values from the mean, okay? And so here's what I want us to quickly do before we learn how to actually calculate this. And I'm going to do more direct instruction on this than normal. But right here, okay? No, come back. Okay, so we have this data here. All right, backpacks, data. All right, so you see we have some data right here? Okay, so I'm going to put the mean in. Oh no, I don't want the guess, I want the action. All right, so there's my mean, right here. And let's try to guess the standard deviation. So when we say standard deviation, we literally just mean the average distance of those points from the mean. So what do you think might be an average distance from the mean? You'll notice there's this little box here, and so I can spread it out. So let's start really close. Does that look to be like an average amount that those data points deviate from the mean?
No.
Okay, so let me know when you think we kind of get to an average.
There.
Right there? Okay, so let's see. Okay, so notice down here, a little bit wider. All right, so that is statistically what we mean by the average distance from the mean. And I'm going to show you how to calculate these things in a second. So let's do another one. And you can actually look at the context of all this stuff later, but all right. No, go away. Dang it. Well, can't do that one because I actually already showed it. But notice in this case, I want you to notice this standard deviation is actually way further out than the majority of these data points. Why is that standard deviation past most of the data points if we're talking about an average distance from the mean?
Because it's counting all of
Yeah, so it's
besides the outlier.
being influenced by this outlier, maybe these are outliers, right? So that's interesting, right? So standard deviation is not just like the majority of the data points, it really is an average distance of those data points. Let's look at one more. Okay? Alrighty, so here's our guess, right? Okay, so that's a weird set of data, but let me know when you think we get to an average distance from the mean.
Yes.
Right there? Okay, that got a little bit wider, let's see. Okay, we're almost there, right? So notice that is a average, whoa, not that. That is an average amount that the data is different from the mean, right? So we have the mean in the center, and we have this average amount that it differs from the mean. That's what we're talking about when we are talking about these next things. Now let's learn how to calculate this. So if we're trying to find an average distance of the values from the mean, what's the first thing we need to calculate? Well, we need the mean, yes, which I think they gave it to us, right? 65 degrees. So we need the mean first, then what? We need the distance from the mean. So how far is 65 from 44? Or how far is 44 from 65?
41.
Close. Why would it be negative? So it's 44 minus 65. There's another kind of conceptual thing I want us to think about. Why would 44 be negative?
You lose it. It's to the left.
It's to the left, right? When we think about the left side of the number line, aren't the left side of the number line my negatives? Yeah. Why is it negative? Oh, because it's to the left. Okay, so 51, how far is it from the mean? Negative 14. 61.
Negative 4.
65.
0.
80.
15.
89.
24.
Okay, so we should have already done this, hopefully. Now, this is interesting. Why in the world, so if I was to ask you to find the average distance of the values, what do you think you would do with these numbers?
Add them.
You would add them together and divide by
8,
7,
6, right? Can someone really quickly do negative 21 plus negative 14 plus negative 4 plus 0 plus 15 plus 24 in their calculator? So add up those distances from the mean. Oh, it's 0. Well, that's not very very helpful if I want the average distance from the mean, right?
So we can't use it.
So we can't use it as is. Why can't I use it as is? Because there's negatives and there's positives that balance out to the mean, right? Okay, so the negatives is my problem, so what can I do? I can what? I can square it.
Absolute value?
Or you can use an absolute value. I'm glad both those came up. So what we have found, and we're going to talk about what's called a biased estimator and an unbiased estimator over time. And so it would make sense to just do an absolute value. But what we found is when we use an absolute value for here, and we find the average doing that, it gives us what's called a biased estimator. And you don't understand much about a biased estimator yet. That'll come up right after probability. But does that sound good? No, biased means it is consistently missing the mark, right? And so we don't use an absolute value. What do we use? A square. All right, negative 21 squared. Hopefully we already did this. Hopefully somebody. What is it, 441? Negative 14 squared, I think, is that?
Yes.
Is it 576 for this last one?
Yes.
Sweet. And then notice what do they ask for down at the bottom here? The total, because if I want to find the average, what do I need to do? I need to total them. I need to add them, find the sum, right? So what was the total here? 1454. And then so what would I do to find the average of the distance from the mean squared? What do I still need to do? Divide by 6. Okay? And so what do I get? What do I get?
77.3.
Give me the decimal. What did you say, Madeline?
242.3 repeating.
242.3 repeating. Okay? I gotta ask you. Does that look a whole lot like, I don't know, the distance that these numbers are typically from the mean?
No.
Oh, that's right. We squared it earlier, didn't we? So what do we need to do? We need to take a square root. Okay, so we need to now take a square root. So the square root of 242.3 repeating is equal to what? 15 point what?
5, 6.
Okay, I'll stop at 5.6 degrees Fahrenheit. Let me ask you, does that kind of make sense as an average distance from the mean?
Yes.
Yeah. Okay. So let's break this down. Okay. Actually, now is what I'm going to address. What has been reminding me to pass out all day today. I don't know if I've mentioned this to you, but I love AP statistics. That alone, yes. But two, they give us the best formula sheet ever, and they let us use a calculator on the whole exam. It's fantastic. Don't let me forget to give Andrew this formula sheet tomorrow, since he's been bailing on us forever, stupid COVID. Or sickness in general, I don't know. I bet he's just trying to skip school. He seems like the type, doesn't he? Okay. So, does anyone see anything on that formula sheet that looks kind of similar? So notice we are under number 1, descriptive statistics. Anything that looks kind of similar to what we just did?
The mean. Wait.
So we did the mean to start.
Well, in that first one.
So the first one, remember, that's the mean, right? So we did the sum of x sub I divided by n. That got us our mean of 65.
Is it the second one?
The second one, let's look at that second one, s sub x. Now the average distance of the mean. Something that is average is something that is typical, or it is the standard. So we found the average distance from the mean. So we found the standard deviation. The standard or typical amount that the data deviates from the mean. That's what we just found. Now we did make a mistake, not really a mistake, but kind of a mistake, and I'll explain why in a second. So notice this formula. Don't ever use that first square root formula. It's stupid. I don't know why anyone would ever do it. Use this one. So let's start on the inside actually. So what do we have going on the inside? We have the, what's this sigma mean again?
Mean.
Oh.
The sum, the total, right? So sum all of the values minus the mean squared. Did we find all the differences? And then we squared them? Notice it says x sub I because what I would consider this is my first data point, my second data point, my third, my fourth. That's why you will see me write x sub I, because that x sub 1, x sub 2, x sub 3, x sub 4 is the first, second, third, fourth data point, okay? So we're going to find the differences, we're going to square it, and then find the sum. But I want an average, right? So what do I need to do to find an average?
Divide.
Divide by, now we divided by n, didn't we? What's the formula say?
N minus one.
It says n minus 1. I'll explain more about that later as we go along, but I'm going to show you something else in a second. Now, we divided by n, the formula sheet does say n minus 1, but again, we ran into the issue of like, that's way too big. Why? Because we squared it, and so what do we need to do at the end? The square root, okay? So there's that. Now, what I want you to quickly do is I want you to pick up your TI Inspire. I want you to put those 6 data points into an Excel file or a list and spreadsheets page, and then I want you to do the one variable statistics calculations for me. So you need a calculator, put that data in. Was it Colorado, Denver?
Yeah,
Whatchamacallit?
correct.
44, 51. If you're struggling with it, please let me know after I finish, / talk with a table mate.
Oh, I didn't do this.
That's fine. Wait, no, just do Denver. Yep, just do the one variable statistics with Denver. Alright?
It's not letting me do it.
Yeah, so remember those are the same as these right here. Yep. Make sure you go under, yep, label your variable.
Why is it not letting me label my variable?
Oh, because your variable's not mean. That, it's calculating an average if you type in mean, type in like temp or Denver,
Oh, okay.
right? And then you're gonna put those temperatures in. Okay, hit enter. Now remember, those are the deviations. You need the actual temperatures. Yes, guys, you need the temperatures, not the deviations.
Oh, are you putting the distance from mean?
No, do the one variable statistics in the calculator. So put the temperatures in. Nope, hit escape. You guys start in cell 1. Yep. Okay, so go ahead and head up to the top of that data set. Or of the calculations, yeah. Alright, hopefully we're there, almost there. Talk to a friend if you're still stuck, because we gotta know how to do these stat calculations quickly and efficiently for the AP exam. Okay. Yeah, you can do that, but it's better if you practice applying the variable. It just makes it work better. Okay, so, hold on a second. Shouldn't the, oh yeah, 65 point something. Okay, so I want you to notice we calculate our standard deviation to be what? 15.56 degrees. Anybody see that on here?
They got 17 on
Hmm.
it. 17?
Well, but look again. Do you see that 15.56 anywhere on here?
Yes.
Yes. Notice that's under that lowercase sigma. This lowercase sigma, we use Greek letters when we're talking about, does anyone remember? I mentioned it before, with x bar versus mu.
Oh, wasn't it the population?
So remember, x bar, that's my sample mean, my statistic. Whereas mu is my population mean or parameter. That sigma is my population standard deviation. So the population standard deviation would be that 15.56. Okay? And so what that means, because it took me way too long to realize this, if I had a population, note I said if I had a population, that would be my standard deviation. Do we have a population? No. So remember earlier how I said we don't use the absolute value because it is a biased estimator? If we divide by n, so if we did and we divided by n, notice I'm using the capital N for population. If I did n like that, it would be a biased estimator of the population. If I only have the sample size, or if I only have a sample, then I have to do n minus 1, and now it is no longer biased. Okay, so we have to use n minus 1, so it is an unbiased estimator. That's why that's happening. Okay, so I want you to understand where that's coming from, but I do want to point this out. How often are you going to have to calculate standard deviation by hand?
Not, never.
Never. You need to understand the formula, and you will have the formula sheet, but you also have a calculator the entire test. Okay, so keep that in mind. Any questions about this average distance from the mean? Yes, ma'am.
Why was the minus 1 got in again?
So why is it? So one, remember I already talked about it, or I mentioned the idea that it's an unbiased, or this makes it an unbiased estimator. Okay. The reason why it's n minus 1, we'll go into more detail about this later. If I had the population mean, notice if I had the population mean, because I have the population, I can divide by n, the sample size. But do I have the population mean?
No.
So I am estimating that mu with x bar, so I have to do n minus 1 because I am estimating mu.
Shouldn't
So
it
that's
be,
why it's an n minus 1. Huh?
shouldn't it be just n then?
What do you mean?
Shouldn't it be just n instead of n minus 1?
No, that's not. It would be n if I had the population mean. If I don't have the population mean, then I am estimating one parameter, so it's n minus 1. We'll go into more detail about that later, but we'll see stuff where we are estimating 2 parameters, and so we're not going to use n minus 1, we're going to use n minus 2. That's why that is divided by that. And so I'll explain more about that later, but that's why it's n minus 1. Okay, now we should be able to fill in the rest of this as well. So, using our calculator, what's the sample size? Well, we should know that already. By the way, you'll know, look in the calculator. I want you to find in the calculator where it tells you sample size. So, row 7, right? Oh, you have an extra data point in there somewhere that you need to take out.
Why did all my stuff just
I thought
disappear?
So your stuff was off, huh?
My stuff just disappeared, what's that?
I don't know. But if you look at row 7, it tells us our sample size is 6. What's our mean?
65.
Oh, it just disappeared.
What did y'all do to make it disappear?
It's just doing that.
Just
gosh.
hit escape. Guys, just hit the up and down arrows. Okay? Just hit up and down arrows. So the mean is 65 degrees. So what's the standard deviation?
15.57.
Remember, if it was a population, it would be 15.57. But we don't have a population, we have a sample, so it is 17.05.
0.05.
So remember, if you have a population, that's when you use sigma, the lowercase sigma. But our standard deviation is the S in there. All right, minimum. Now we can clearly see the minimum just in our data set, but does the calculator tell us the minimum? What is the minimum in the calculator?
44.
So make sure you zoom down. What is it? And it says minimum, doesn't it?
It says MIN.
M-I-N for minimum, right?
Yeah.
Q1, 51. And we'll talk about what Q1 is in a second. Median,
63.
63. Q3, and max, 89. Okay? All right.
Is that what the median at the top half?
So that's what we're about to talk about in just a second. Okay. So please note, once again, I am going to teach you what those things mean, and I need you to know what those things mean. But the calculator can do the actual calculations for you. Okay? The calculator can do the actual calculations for you. Okay? So, number 5 says, let's add one more day to the data set, a very cold day, with a high temperature of only 7 degrees Fahrenheit. Add this value to the data set and record the new summary statistics. So if you go into the TI Inspire and you add one more data point into that column, it'll automatically update everything, I believe. So go ahead and add one more data point, 7 degrees Fahrenheit. And I believe it updated everything, did it not? So fill in your data, hit escape.
Yes. No, I don't know why, but I didn't have the right
Yeah.
volume for some
Yeah,
reason.
7.
I actually didn't have the, 17.05 on hers.
I think you put the wrong variable in, because you have the variable scores here, okay? My guess is when you try to go down, you accidentally downed into scores. So hit enter for Denver. I'm gonna make sure this overwrites the data you already have. See, you put the wrong variable in there. Okay. All right. I'm gonna give you one more second or so. Maybe talk to a group member if you are stuck getting that value, but we're gonna talk about it in just 1 second. Make sure I'm not forgetting what's in this lesson versus the next. Okay, so they talk about the quartiles a ton next time. Okay, that's what I thought. Okay. Alright, so let's talk about this. Alright, so what is the new sample size? What is it? 7, new mean?
56.7.
Alright, standard deviation?
26.8.
26.89.
What number? I wrote 24 but I don't know which number actually.
So are we supposed to use S or the lowercase sigma?
The lower sigma. Always.
Remember, that sigma means the population standard deviation. We don't have a population, we have a sample. So remember, that's why on the formula sheet it says SX, right? So we have S, the sample standard deviation. I believe that is the 26.89, is it not? Yep, okay. All right, what's our minimum now?
8. 7.
7. Be careful, make sure you have the right data point. Next one's 41. Then 44. Wait, no.
No, my bad, 41 is
Q1 is 44.
What's
Q1
median?
is
Oh my gosh.
Oh, Q1 is 44?
Yeah,
Jeez.
Q1 is 60. What?
No,
Median is 61.
Okay,
Q3 is 80.
80.
And 89.
Yep.
okay. So, how did these things change? So, when we added this new 7 degrees in there, first off, what do you think we might consider this 7 degrees Fahrenheit data?
Outlier.
Ooh, back up.
Potential outlier.
Oh yeah, at least for right now, we're only gonna call it a potential outlier. Tomorrow, or not tomorrow, hopefully in a minute, we'll get a chance to actually talk about if it actually is an outlier. But we'll finalize that tomorrow. So, it's a potential outlier. How much did that affect these values? Really focusing on the median.
If, no.
It lowered it?
It lowered it by how much?
2.
So did it lower it by a lot? 4, right? Wasn't it 60? Oh no, the median was 63, yeah. So it only lowered it by 2. So that potential outlier, did it really affect the median?
Not
No.
that much.
What about the mean and the standard deviation?
A lot
It
more.
did a lot.
It affected a lot more, right? So what does this tell us?
It is a potential outlier.
Well, there's that, but also, it's something we've already referred to. The mean, and also apparently standard deviation, are heavily affected by, and they're affected by outliers. I'll go ahead and say that. We just can't say this is an outlier yet, but they are heavily affected by outliers, also by skewness, right? The mean and the median, or the mean and standard deviation, well, the mean's gonna be pulled towards the outlier slash the skew, okay? So what about the median?
Not very effective.
Yeah, the median is not affected by outliers much. Okay. Alright, so we actually have terms for that I want to introduce to you. If I can find my purple marker, there it is. The terms for things that are heavily affected by outliers is they are not resistant to outliers. So guess what the median is?
Resistant.
Oh yeah, the median is resistant to outliers and also some skewness. Okay, so the median is resistant to outliers, the mean and standard deviation are not. So if you have outliers, if you have skewness, what are you going to use? Median. If you have outliers and skewness, what are you going to use? You're going to use the median. If the data is roughly symmetric and there are no outliers, because you can have symmetrical data with outliers, but if it's roughly symmetrical and there's no outliers, you're going to use the mean.
Mr. King,
Yes?
in the, I was just, there's a lot of terms, I was just a little confused. Standard deviation means that this is the average distance from mean. Right?
Correct. Standard deviation is the average distance from mean. Okay? So how would the average distance from the mean for San Francisco compare to Denver?
A lot closer together.
So it would be a lot less, right? The average distance for the mean from San Francisco would be a lot less than for Denver. Okay? Alright, we gotta do quick notes somewhat quickly. Alright.
Wait, just hang on, take a picture real quick.
Okay, so the main part of this learning, or this lesson, is the standard deviation is the square root of the sum of x minus the mean squared divided by n minus 1. Now, the one thing I have not addressed is how we interpret that. Okay, so I'm going to talk about that in just a second. So get that formula down. So, what's up?
There you go.
Thank you very much.
You're welcome. Eli, you got hand.
I got it. We're good.
Eli.
Alright, so standard deviation. If anyone ever asks you to interpret what the standard deviation it means, the typical, remember how we talked about standard deviation? It's something that is typical or standard, right? So the typical what? It's a typical distance. The what?
The value has, the data has with the mean.
So the data, make sure you include the units, or the, more importantly, the full context, right? So include your context there. The typical distance the data differs, or typical distance the data, differs from the mean, or deviates from the mean. Is blank. So if you're trying to interpret standard deviation, that's how you do it.
So in the lesson that we just did, what would the context be?
The temperature in Denver typically differs from the mean by 17 point whatever degrees Fahrenheit. right? So the typical, I guess really I need to be better precise, high temperatures, right? Yes, Charlie?
Sorry, I don't really understand what that equation means.
So remember how we took each value and we subtracted the mean from it to find out how far it was from the mean, right? And then we squared every difference to make them positive. And then we added them all up because what we're trying to find is an average. And then we divided by how many there were. Now, we had to do n minus 1, so remember I told you it was a biased estimator if we just used n. So the average in this case is n minus 1, and we took the square root. Now, I think part of that was because you were doing some career models, weren't you?
So the slide has six, okay, six, so if I say data points, I divide by 5.
Correct.
Alright.
Alright, last thing I want to point out with this is that's called standard deviation. Notice I could square both sides and I would get this formula. And this is really what we have when we start. This standard deviation squared is called variance. That's another name you need to know. So the variance is the standard deviation squared. Yeah, we're not getting to that next lesson. We'll do the next lesson before we do the DYU tomorrow. And I'll just put, yeah, the DYU tomorrow.
Oh, I think I missed that.
Learning target number 2, what we need to recognize is outliers, or we should say mean, yeah, I'll title this outliers. The mean and standard deviation are what in respect to outliers? Not resistant to outliers, but what is? The median is. The last thing that we need to add on to this then is if the data is roughly symmetric without outliers, use what? Use the mean and standard deviation. Otherwise, use median, and I'll teach you what this is tomorrow, IQR. Okay, so I'll teach you what IQR is tomorrow, but IQR is the measure of variability that goes with median. Okay. Sorry that I was so rushed. I'll make a decision. I will say this, I'll just shoot out an email. We may move that DYU to Tuesday, but I don't know. Would y'all want it on Tuesday, or do you want to, yeah, I didn't think so after a long break. So we'll do 1.5, we'll DYU after that, and then start the next part of this unit. Yes, sir. Have you looked in the textbook yet? Look in the textbook. What time are you getting home tonight? If you have, listen, I would prefer you to read through the textbook to find as much of that information as possible. If you have to turn it in on Tuesday after the weekend, then do that, okay? Okay. Yes. But not for long, I gotta go home after now. So, but yes, for a little bit. Thank you.